Righto, year 10, I'm going to go through the sine rule now. I did it in class yesterday, but a couple of people were away, so let's have a look at it. Now, up until now, you've been under the impression that all trigonometry only works in right-angled triangles. And this is true to a certain aspect. Let's have a look at a non-right-angled triangle, and I've drawn one here. And I'm going to label it, but there's no right angles in this triangle. So let's label it. So we'll call this side, this vertex A, this vertex B, and this vertex C. Now, one of the conventions that we have when we label a triangle is that the opposite side to the vertex becomes this lowercase letter. So if I look over here, to this side, I'm going to call that little a. And I'm going to do the same to all the other sides. So this is going to be little c, hold on, and this is going to be little b. So now that we've got the labelling out of the way, because we can use the lowercase to label the sides, and we can use the uppercase or the capitals to label the vertex or the vertices. Now, the problem is at the moment we don't have a right angle in there, but that's okay, because what we can do is we can drop an altitude. Now, an altitude is a line from the vertex that hits the opposite side at 90 degrees. Now, I've deliberately drawn a scalene triangle because if I were to do this in an isosceles or an equilateral, it would bisect the base and would give us the same rule, but it wouldn't be a case for every triangle. And we want this rule to work for every triangle. Hence the reason why we're using algebra. We're using pronumerals instead of numbers. And if it's just a scalene triangle, that means it works for every triangle. So I'm going to call that altitude h. And what I'm going to do now is I'm going to find h in both sides of this triangle. Indeed, you can think of it as two triangles. You can think of it as the triangle on the right-hand side, just this side, or you can think of it as the triangle on the left-hand side, this side. So first of all, let's look at the triangle on the left-hand side. So what do we know? Sine, using right-angle trigonometry, sine of A. So sine of this angle here, well, that's pretty easy. It's opposite, which is h, over hypotenuse, which is c. Now, because c is a pronumeral, I can multiply it, or a numeral, a pronumeral, it acts as any other number. I can multiply it across, so I can get c, little c, sine A equals h. Now, if I look at the triangle on the right-hand side and I have a look at this angle in here, and I can write something equivalent, I can say sine C equals opposite h over little a. And again, I can multiply the little a across and get little a sine C equals h. Now, because h is the same, it just exists in both triangles. It exists in the centre of the original triangle. I can now equate these expressions. So c sine A equals a sine C. Now, we do remember that sine A and sine C are both numbers. So I can treat them as a number. So I'm going to divide by sine A, and I'm going to divide by sine C, which will effectively put them as a fraction on the other side of the equal sign. So I'm going to get c, and the sine c when I divide just goes underneath. I hope you realise that when I divide on the right-hand side, the sine c will cancel. And over here, I'll get a divided by sine A. And that is our sine rule. Now, when you see it, you'll see it as 3 because we could have dropped the altitude anywhere. We could have dropped the altitude from any of the other vertices or vertices. And we would have got an h, and all the ratios will be the same. So when you see it, you'll see it written as A over sine A equals B over sine B equals C over sine C. But you never ever use it with 3 or 2 equal signs and 3 expressions on each side. You only ever use it as 2. And all you've got to know is that the side opposite an angle in ratio is equal to any other side opposite the angle in ratio using sine and any triangle. So how does this help us? Well, it helps us answer questions in finding sides and finding angles. So I'm going to do 4b and 5b and see how we go. So 4b, there's a triangle. And I've got this angle and this side, and I've got this angle, and I've got to find that side. Now, whenever you do one of these, always write the pronoun or what you're trying to find first. So x, and the sine rule says on sine of the opposite side, so x on sine 39 equals, well, I just have to find another side and the angle opposite. Well, I've got 22 on sine 57. Now, all of these are numbers. I'm going to multiply that sine 39 across. 22 times sine 39 on sine 57. And then I put that in my calculator. 22 times sine 39 divided by sine 57. 16.5. And we're going to one decimal place. We have another look at it to make sure that it makes sense. And an angle of 57 gives me a side length of 22. So an angle of 39 should be less. Should be less. And it is at 16.5. That's finding a side. Let's have a look at finding an angle. So we'll look at 5b. Again, you need to find the value of the pronumeral. Now, the fact that it's a Greek letter makes no difference. It's standing in for a numeral. So here's what we're looking at, and we've got to find theta. So we can use the sine rule and we can turn it upside down. We can use a reciprocal, the upside down version of the sine rule. It's a ratio. It will make no difference. So I'm going to write sine theta over. Now I'm looking for the side opposite. That's 10 equals. And I've got to write the sine of the other angle, so sine 70 over 12. Now again, they're all numbers. 10, sine 70, and 12 are all numbers. So I'm going to multiply that 10 across. Sine theta equals 10 times sine 70 all over 12. But I still haven't found the solution because I've got sine of the angle. So what I have to do is I have to inverse sine all of that on the other side. 10 times sine 70 over 12. And then I put that in my calculator, and I like to do it all in one go. I don't do it by parts. So over here, shift sine. Put my fraction button in. 10 times sine 70. And you'll notice that the brackets come up every time when you do sine, which is good, over 12. Close my brackets. 51.5. Now they ask for it to be one decimal place, 51.5. But I like to have mine in degrees, minutes and seconds. So I just hit my degrees, minutes, seconds button and I get 51 degrees, 32 minutes and 36 seconds. I rounded it up. And that's how you find an angle. The two methods using the sine rule. And remember, a good method is to always write your pronominal on top. All right, there is another thing you need to be aware of, and it's called the ambiguous case. And we did this one in class. So I'm going to have a look at this. And we did a question in class. So what I want you to think about doing is I'm going to draw a triangle. I'm going to draw a triangle. A, B, and C. I'm just getting the stuff up from yesterday. And I want my angle A to be 30 degrees. I want AB to equal 4 centimetres or 4 units. And I want BC to equal 3. Now this is going to be hard because I used a ruler and a compass and a protractor to do this. So I'm just going to have to do this freehand, and you're going to have to think that I'm using these things. So the first one, I'm going to draw a line. Actually, I'll redo that so I can get a straight line. There. Now, imagine that I have also drawn another line at 30 degrees from here. And it goes on and on and on. That'll do. And I'm going to call this A. And I know that's 30 degrees in there. And I know that's 4 units, so that's B. Now, where does C lie? Okay, so imagine I've got a compass and I set my compass to 3 centimetres. And again, I'm going to draw another line. I have to go all the way back. Where has it gone now? Right, here we are. Let's go back here. So I'm there. I'm going to draw another line. Get it again. Here we go. All right. I might just have to freehand it if it keeps doing this. So I need a line that's 3 centimetres long. So I can I've never used this one before, so I'll get out of that. If I draw a line of 3 centimetres, well, that's not going to be it. If I draw a line of, because it has to be less than this other one. There you go. It could be there. Now imagine I'm doing this with a compass and what I'd get is an arc. But if I continued with that arc, I'd hit it there as well. There's another line that's 3 centimetres. There are 2 possible values of C. There's C there and there's C there. There are 2 cases. So what do? Well, I'm going to call this angle alpha, and I'm just going to get rid of that 30 degrees now. I'm going to write it smaller. And in here, I've got 30 degrees, and that's the other angle. I've got 2 cases where the angle can either be alpha or it can be theta. And they're different angles. Look at them. One is big and one is small. Well, let's just find alpha using the sine rule. So if I use the sine rule, because just looking at the big triangle, A, B, C without the dash, and we're looking at this angle in here, well, sine alpha over, what's the opposite side? 4 equals sine 30 over 3. Okay, so sine alpha equals 4 sine 30 over 3. And I inverse sine that, and I get now you're going to have to do the calculator work because I want to hurry along here. And to the nearest degree, I get 42 degrees when I do that. And you can check it. So that tells me that that's 42, but how do I find this other angle? There exists another angle. There is an ambiguous case here where I get 2 answers. Well, how do I get that other angle? Well, luckily, we know that these 2 are 3, which makes it an isosceles triangle. So that makes the 2 bottom angles the same. So that's alpha. So once you find alpha, you can find the other angle just by subtracting it from 180 because it's on a line, a straight line, and so it'll make 180. So therefore, theta equals 180 minus 42, which will give us 138 degrees. And hence we can find the 2 possible values. Now, how do you know which one to use? Well, you can see it from your diagram. And if it looks like a duck, and walks like a duck, it's going to probably be a duck. And just substitute obtuse in there. If the angle looks bigger than 90 degrees, well, then you're going to go with the obtuse. In the questions that you need to do, in question 11, right, we did 11A and F, they tell you that it's obtuse. So you'll do the sine rule and you will do it exactly the same as this. You'll find the acute angle and then go, oh, but it's obtuse. So you'll just subtract it from 180 and you'll get the angle. So to those people away, you need to make sure you can use the sine rule to find a side, use the sine rule to find an angle, and use the sine rule to find an angle, and then if it's obtuse, subtract it from 180 to find the obtuse angle. Good luck.